Next I'll show you how to take a UHF reading. So this is our UHF receiver. You need this to take any UHF readings. That plugs into the side. Once we plug that in, you'll see that UHF will pop up on the top left, which it has done so. So if I click in that, there's a whole bunch of different ways we can take a reading, same as what the TEV and the cable PD are. But we need to plug in an antenna. There's my UHF Directional Antenna. It's a bit of a bigger one, this one. It's used for testing open air assets, switchgear assets and all that type of stuff. What we do is we plug a cable from our receiver into our UHF antenna. There's a little port on the side here, plugs in, nice and slug, and then we point that at our switchgear or whatever we're testing, the test object. Let's go through the screens. Again, we've got that measurement screen which just tells you what the last readings were and the decibel. UHF is measured in dBm. That usually is a negative number, similar to reception on your mobile phones and stuff like that. You've got a gain level, you've got a frequency level, and that's just telling me what I saw last. Phase plot, this is the one we recommend everyone, or most people, do their readings in. There's a couple of different screens for this. We have our gain setting at the time of test. We have our frequency setting at the time of test. We can tune any of our UHF sensors to go from 50 megahertz all the way through to 1,000 megahertz. We find that is a very good range to find PD signals with our antennas. So we have a phase plot. We can clear our phase plot, and that is the reading that's getting taken right now. Now to change our gain, what we do is we hit our settings button, we go to gain, and we can change that gain all the way from the least you can go is -10, and it will go all the way through to +40. So to become more sensitive, we go up. So the most sensitive that our antennas can be is at 40 decibels. Okay, and then frequency. So we can measure between 50 megahertz all the way up to 1,000, as I said before. We can change that setting and look at individual megahertz ranges. So if we click on the setting button, we go to tuning frequency, and then you'll see this 800 will go up if I press the up button, and it will go down if I press the down button, obviously, and it will go all the way down to 50. Which it's going down right now, and there you go, 47. It stops at 47, and I think it maxes out at 1,000. There you go, 1,000 megahertz. So we can measure anywhere in that range, and what you're trying to do is find a range where it's quiet, because you'll have mobile phone towers and different sources of interference. You want to ignore them, and you want to look for PD in the quiet ranges. So it is tunable, and you can see the phase plot at any of those levels. Okay, so that's those two settings. Another setting that is very useful is this one called wideband mode. If I click wideband mode and turn it on and go back, what it is then doing is this is at its maximum gain, and it's basically, and it all comes in on the one phase plot. Quite often when you do that, you'll get a lot of noise, and it's your job as a technician to figure out if there's any PD pulses in between all that noise. Okay. So that's how that one works. So I'll turn wideband mode off for now. Again, we've got our headphones. We can listen to ultrasonics. We can listen to UHF. We find that UHF, this is a very good use for our headphones. So if I get my headphones, which are these ones, plug that into the bottom here, put them on our head, and we can listen to the sound of PD coming in through our antenna. And when we are picking up PD, it does sound a lot like ultrasonic PD. So that's a very good use of the headphones. So I'm just going to turn that on mute for now. You can do the volume slider for that. We find that when you go to maximum volume, it can be a little bit over amplified. So we go down to around about 70%. Somewhere around there is a good spot to leave your volume for UHF testing. Again, we can go to our PowerPoint and try and get a photovoltaic lock for our phase lock, an E-field lock, a wireless, or a manual phase lock. So all of them are within that is common between all our different test methods. Then the next menu, if we click the settings button again, is our persistence. Again, we can change that so that our phase plot constantly resets itself. And you can see it resetting itself there. It's the same as me hitting pause clear, but it just does it over and over on its own. Okay, so I'll just put that back up to maximum. Okay, so there's another trick that I can show you here, which is a very, very handy trick for UHF testing. What you can do is compare your background readings to your actual test object readings, and that is this one here called spectrum. So if I click on that, what you'll see is this red line going across the screen. And what it's doing is it's testing all the way from 50 megahertz to 1000 megahertz. And you'll find that everywhere you point your antenna, you'll get a slightly different reading of signal. The ones here where it maxes out, here at about the 800 and 900 mark, that'll be your mobile phone networks in the area pumping out signal, because that's where they operate. We want to ignore them and figure out where the PD is. So a really handy way to run this test is if we click on settings, and then we click on this one here, and it says single trace, red trace, blue trace. If I hit red trace, hit tick, then I hit the pause button, what this will do is it'll run all the way to the end, and it will save the red trace on my screen. Okay, and then so the idea is you point this at your background, so off into the bushes or wherever you want to have it, and you get a background trace, and then what you do is you turn this to a blue trace, and you point your antenna physically at something that's got PD in it. So what I'm going to do is turn on my test source. Hopefully I get some PD to come through here. Hit this, hit the restart button, hit the pause button. And what it'll do is you can see that I've got a very high level of activity here. See how the blue line is a lot higher than the red line? That means that my test object is pumping out some signal here, and my background is not pumping out any signal there. So I want to look at what the phase plot looks like in that frequency range. So let's just pick somewhere in the middle, say about 600 megahertz. So what I then do is I go back to my phase plot mode, scroll down to 600 megahertz, and I have a look at what the phase plot look like at 600. All right, so there we go. We're at 600 megahertz now. I know that that test source is pumping out activity at a different frequency to 50 hertz, so I'll just go down to that. We should be able to see 3 lines of activity come up on our screen. And there they are, a little bit less. So you can see there and there and there. That is my test source. It's pumping out 3 pulses per cycle, 1, 2, 3. And my sensor has been able to see that. It's been able to compare it to the background and compare it to the test object and capture the phase plot. So that's how that one works. That's a very useful piece of test kit when you're out UHF testing in the field. Okay, the other settings that we have is this waveform setting. Again, it's the same as the one that we were looking at with the TEV and the cable PD. You can look at the waveforms coming through. You can zoom in on them. The faster and sharper they are, the more likely they'll be PD. And then you've got your 3D phase plot mode. So you can see here that we've got 3 pulses per cycle coming through. You can pause that, take screenshots of that, and all that type of stuff. Now there are a couple of different UHF antennas. I'll show you them all right now. So the one that's mainly used is the one that I showed you before, which is this one, which is the directional antenna. We then have what's called a whip antenna. So if we disconnect that, we have this one here. This is called a whip antenna. This is not directional, but you can use this to walk around a switch yard and figure out where your PD signals are highest, or your whatever you happen to be testing. And then the third one is this one here, which is called a GIS sensor. You place this across the spacer gaps of GIS switchboards, and you look for PD that's coming out through those spacers. Now those spacers can't be made out of metal, they have to be made out of something other than metal, plastic usually. And the PD that's within the GIS tubes will come through, and it will come through this black sensor here. You basically place these 2 ribbons on either side of the band joint, have the plastic part of the switchgear go through there, put that on your switchboard, and then do all the measurements that I just told you to figure out if you've got PD. And that's UHF.